we just described, the most popular data management tool, big data management tool, which is Hadoop. And inside that, we have HDFS, and which is more the hard disk system. The MapReduce, which is the method, and also the operation system, plus many other things like a Google Drive, Dropbox, those kind of functions. Now, this video shows how it looks like for a programmer to use Hadoop system. Yeah, I forgot it's not working here. For some reason, this PowerPoint is weird. I cannot select anything. No.
This course is about machine learning.
Let's take a look at how MapReduce actually works by running a MapReduce program and looking at the output. So as you remember from previous lessons, MapReduce, essentially you create two programs. One is a mapper, the other is a reducer, and you give those programs to Hadoop, which then will distribute them among all the nodes and run the mappers against all the files that feed into your process, and the reducer will take the output of each of those maps and put it back into some output that you can actually use. So what we're going to do is run a MapReduce program that will summarize the word count in a bunch of books. And those books we looked at in a previous lesson are these. So we have Beowulf and Great Expectations and fairy tales and so on.
And you can imagine this is
so the input files that we have are a bunch of unstructured data. You don't get more unstructured than this. A lot of words in here. And we're going to do something very simple just to summarize how many times the word squashing occurs between all of the books. So we're going to combine them all together and analyze them. So fairly straightforward. Let's see how we do that. So here is a list of commands that will do the entire process. We'll just take them one by one. So here we're going to use DFS to put the data into HDFS. That's actually what this second command does. And we did that in the previous lesson.
HDFS,
and the next command
is kind of location
is going to remove our output file. So we're going to summarize all of these text files, and we're going to dump that into a folder called words by book. This command just cleans out that folder so that there's nothing in it when we start.
This is kind of old doc system creating new
Here's
folder.
The program that really kicks off MapReduce. So this is some, we have some cleanup to do beforehand. Then the MapReduce is going to really analyze the files. And our mapper program is this. It's this BookTextMapper. And our reducer is BookTextReducer. Let's take a quick look at those and see what those look like. So here's BookTextMapper. All this is going to do is it does ask the environment, what file am I working on? Because it needs to know that. And then for every line in the file it's been given to work on, it's going to just strip out spaces at the end, split the line into a list of words. And for every word in that list, it's going to print a line. Here's the file name that I'm working on. Here's the word that I just saw. And then it's just hard-coded as 1. The mapper doesn't try to summarize how many times the word occurs. It just creates the detailed leaf data that then the reducer will summarize.
So this one basically shows that the kite, just 1, and deer, just 1. And this is mapping, and reducer will take care of the aggregation later.
That's the mapper. And we can test that mapper to see how it works. Let me just open a command prompt here. And I'm going to go into my Hadoop. I have some code samples. If I go into MapReduce, actually I have a script called testmapper.sh, and that's going to take one of this book I have in my local folder, put it into the screen, and then run the mapper test on it, which is basically the same script we looked at, and then see what it does. And this will help just so you understand what the mapper is producing. So the map,
this is kind of like a guy that is counting the number of fans, right?
Is producing one line that has the file name, the word it saw, and 1. But these are detailed files, so you'll have to kind of look that they won't summarize the data. So in here, the word the was detected, and that number 1 was kicked out. But before that, the was detected against up here too. So the could appear many, many times within this file, and every time being counted as one. It's the reducer's job to add up all the ones. So let's look at that reducer program. So if I open the reducer and take a peek at it, the reducer is a little more complicated because it has more work to do. What the reducer is going to do is take the output from the mapper programs, split that by that pipe character that we use to delimit within the file name and word. And so it'll get 3 arguments. One will be the file name, then the word, then the number. And there's just a loop in here. So it will loop through, and as it's given its data, which will be sorted, it will detect whenever the word and file changes and kick out a summary line for that. So here's the current count. So at the end of the reducing process, all those the with 1 will turn into the with how many times that occurred. And then that will get aggregated among all the books that got summarized by all the nodes, and then were combined. So that's what that is going to do. Essentially, it's going to transfer the code. This is going to move the code.
And what he was doing, this is called like the parent code that he is using to call, those methods, and he was just opening those methods to show the detail. But this one just calling different methods now.
To the data, and Hadoop's going to do that. And then when that's all done, the output is going to go into this folder called User Hive Warehouse Words by Book. We're putting it in Hive because in a subsequent demo from
Hive is what? Hive is in the Hadoop is kind of like the Google Drive. Remember that? Yeah.
This one, we're actually going to turn that into a Hive table. But in this case, it doesn't matter. It just is a file that we're going to put into an output folder. And then down here, I'm actually just a little bit of demo, just copying back that words by book file so we can look at the output of the reducer. So let's go ahead and run that. And it's going to do all these steps and they'll kind of fly by, but so pay attention. Oops, not test. So it's going to be run full shell. So that's going to.
The full shell means it's executing the parent method that's calling all the children methods, right?
Delete the files, as you can see, it deleted them. And then it will actually copy them all back into the folder again. And now the MapReduce job is running. And what you can see going on here is it says running job. And to the console, it will actually start telling you how much of the mapping is done, how much of the reducing is done. So this is a batch that's running. Another way to monitor that batch is from a web view. So if I come into this folder and refresh this, I can see in my running jobs, I have this streaming job running. That's the one I just submitted. If I click on that, I can actually see the progress of that job. So it has 28 total maps. 2 of them have completed. Reduces just one reduced job. None of that's been done yet. And as the job runs, I can actually see this will change and it will progress. So I don't have to be on the console to see the progress of this job. I can do it from this web view. From the console, it looks like that. So remember, every file is being passed through a mapper, and then the reducer, as soon as 2 files are available, the reducer can start reducing. Then as more come through, it can continue.
This is also important. The reducer does not need to wait for all the mappers to finish job. It's kind of like when the guys calculating, clicking the number of fans, as far as 2 of that sitting areas are done, the reducer can start working.
Again, web view, terminal view. So I'll stay in the terminal. So we can see this finishes up and the map will get to 100% before the reduce. But then once the reduce is 100%, then the job is done and we can look at the output. Okay, so to the console, we've been logged a lot of information. So the reduce finished tells us it completed successfully. And then we get various statistics like how many bytes were read, how many were written, and so on. And the meat of it is, this is the output of that. So user, Hive, warehouse, words by book. If I go back to the system, I can look at where that was written, warehouse, words by book. And since the output is relatively small, it's only 24 megabytes.
Did you guys see this 64? Because this was an old video, and now it's 128, right?
Didn't exceed the block size. So we really just got the one part, one file. That's fine. If this is a very large job, we might have multiple files here that together make up the entire table, if you will, of words by book.
And you see this replication? Default is 3, but for this guy, he just showing that, so use 1, right? But maybe for Apple, when they are doing this kind of uploading and downloading of your picture, this is definitely more than 3.
But this one just has 1. And if we look at that, now we can see that Arthur, with an exclamation point, occurred 10 times over the course of all of those books. And then as I scroll through, I can see how many times various other words appeared. I can also see opportunities to improve my script. My script isn't getting rid of these punctuation marks, so I'm actually getting nothing question mark and nothing period as being different. And subsequently, we'll fix that later, but now you can get the idea. So later on, we'll actually take this and push this back into SQL Server. We'll make Hive tables with it and do some various different things. But that's effectively a basic intro to using MapReduce and creating MapReduce programs.
Yeah, that's actually a very helpful introduction. Now think about that. What he did was just trying to calculate how many words in the books, but I don't know, guys noticed the raw file he put into this Hadoop system, that was around like 8 gigabit, right? So it's just to find the numbers of words from that, it takes so long. He actually skipped a lot of progress. Now imagine this is only counting things. And for Amazon, this is kind of like counting how many people purchased this particular item. And now if you want to do query, if you want to say, hey, look for this flash drive on Amazon, that means another set of different ways of looking for information. And that is big data. Although the logic is very similar to finding a number in your Excel or calculating frequency in your Excel, but because the big data is what? So big, so fast, so different, so diverse, that none of the traditional way of storing and doing all things wouldn't work. And we have to rely on this special tool, Hadoop, to do that. That's big data. And just a little bit about other things like a DAG model. This is the directed acyclic graph model. I'm trying to use just the plain language to explain that. This is more of the relational table. So for example, if you want to generate some data set to show the family relationship, and when you are looking for this ID of the father, you also want to see the ID of the son, it's probably not effective using Hadoop in that case. You probably also want to somehow picture or map the relationship of the data set. If that is your purpose, it's better for you to use this DAG model. And DAG model actually, the most popular tool is this Apache Graph X model. And like I said, it includes the data nodes and another layer to describe the relationship of the data nodes. So for example, like using the case of a professor and students, let's say if we are building a worldwide database for all the professors and their PhD, their graduate students, then it's not Hadoop. Okay, Hadoop is not designed for that purpose because it cuts and shuffle all the data, right? It's more like Professor Eric Du, and let's say Gilbert, he's my PhD student. So we have a node to store all his information. I have a node to store my information, but we have another layer called is the advisor of. And then we will describe that, we will save that information in both my node and his node. So when you are trying to find the relational data, you can definitely find that. But this is a simple case. It probably sounds very simple, but now imagine we are having this, like, for example, Gilbert also has friend. So maybe there's another relationship called is a friend of. Gilbert also has parents, so is the parents of, right? And his friend might be also my student again. And might be my friend, right? So now imagine if you're talking about big data, that kind of a network will become so complex. And if you want to find just the most interesting relationship, that can become problematic. Then we need to use some mathematics to streamline or simplify that process. And this is about the graph theory, how to cut that. I don't want to dig more into this because this is probably less relevant compared to Hadoop. But have you guys heard about the bridge salesman, problem? It's kind of like you have different places to visit, but in this city, you have this many bridge. So what is the shortest path for me to visit all the places without repeating too much of the routes, right? That is based on graph theory, like how I can plan out the search of that path without too much waste. And that is how graph theory is used in GraphX, this particular tool for the DAG method. Make sense? And this is the Kafka, which is the big data streaming data. Remember that when we talk about big data tools, we have different needs, like the overall processing storage, and we also have streaming needs. Streaming needs means I collect data, I analyze, I output data all at the same time. That's called streaming. So let's see if, and this is a tool, the Kafka is the most popular for the streaming big data analysis. And let's check how it works. And it's not working. How can I check the? For some reason, it's not playing in Excel in PowerPoint. Let me search for that. Maybe I just find another video.
So before we learn about Kafka, let's learn how companies start. At first, it's super simple. You get a source system and you have a target system, and then you need to exchange data. That looks quite simple, right? And then what happens is that after a while, you have many source systems and many target systems, and they all have to exchange data with one another, and things become really complicated. So the problems is that with the previous architecture, if we have 4 source systems and 6 target systems, well, do the math, you need to have 24 integrations to write. And each integration, as you may or may not know, comes with a lot of difficulties around the protocol you have to choose, which is how the data is transported. So TCP, HTTP, REST, FTP, JDBC. Then the data format, how the data is parsed. So binary, CSV, JSON, Avro, Rift, and others. And the data schema and evolution. So how the data is shaped and how it may change in the future. Additionally, each time you integrate a source system with a target system, there will be an increased load from the connections. So how do we solve this? Well, this is where Apache Kafka comes in. So Apache Kafka allows you to decouple your data streams and your systems. So now your source systems will have their data end up in Apache Kafka, while your target systems will source their data straight from Apache Kafka. And so this decoupling is what is so good about Apache Kafka, and what it enables is really, really nice. So for example, what do we have in Kafka? Well, you can have any data stream you can think about. For example, it could be website events, pricing data, financial transaction, user interactions, and many more. Additionally, once the data is in Kafka, you may want to put it into any system you like, such as a database, your analytics systems, your email system, or your audits. So why would we even use Apache Kafka, right? Well, it was created by LinkedIn, and it's now an open source project, mainly maintained by a private company called Confluent, but it's under the Apache stewardship. It's distributed, resilient architecture, and fault tolerant, and basically it scales. It scales horizontally. There are Kafka clusters with over 100 brokers. It can also scale, and it's proven by LinkedIn and many other companies that it can scale to millions of messages exchange per second. That's quite a lot of scale. It is extremely high performance. The latency to exchange data from one system to another is usually less than 10 milliseconds if you have good machines. And this is what we call real time. Real time means that the latency is really, really low. Overall, don't believe me, right? You can believe 2,000 plus firms, 35% of the Fortune 500 that use Kafka, such as LinkedIn, Airbnb, Netflix, Uber, Walmart, and so many others, right? Everyone uses Kafka or is thinking about using Kafka, and you should learn Kafka, and you are at the right place. So use cases for Apache Kafka. Well, it could be a messaging system. It could be used for activity tracking or to gather metrics from many different locations, so such as your examples or your IoT devices, gather logs from your applications, stream processing, and we'll see that we can use the Kafka Streams API for that, and decoupling of system dependencies, so reduce the load on your databases and your systems by decoupling them, or perform big data integrations, for example, with Spark, Flink, Storm, Hadoop, and other big data technologies. So this is quite a wide array of use cases, and this is why so many companies are using Apache Kafka as their backbone in their company. Now, if I want to get you concrete example that get you a bit excited about Kafka, that make you understand what Kafka is used for. Netflix is using Kafka to apply recommendations in real time while you're watching TV shows. And this is why, basically, when you leave a TV show, you'll get a new recommendation right away. Uber uses Kafka to gather user, taxi, and trip data in real time to compute and forecast demand and compute the almighty search pricing in real time. So Uber uses Kafka extensively. LinkedIn uses Kafka to prevent spam on their platform, collect user interactions, and make better connection recommendations, all of that in real time. Basically, as you can see, all these companies are using Kafka so that they can make real-time recommendation, real-time decisions, give you real-time insights to their users. And this is why it's so good. Now remember that in this, Kafka is only used as a transformation mechanism. People need to still write their applications or web applications to make things work, but Kafka is really good at making your data move really fast at scale in your company. So that's it for a quick introduction to give you some insights about what Kafka is, how it works, and where it sits in companies and how they use them.
So in general, Kafka, you can imagine that, a messenger system like on Facebook, there are some popular Facebook owners that they receive message from 1,000 people. And meanwhile, for one of the 1,000 people, that he's also sending message to another 1,000 people. If you have this one-to-one connection, that will be a very complex network of connection. And if you want the processing to be faster, that is almost impossible. So Kafka is more kind of like a restructuring mechanism. Like instead of I'm talking to you, I have this layer. Like if I send a message to you, I'm actually not sending that directly to you. I'm sending this to a Kafka server. And then this Kafka server will count, okay, if I'm sending this message to 100 people, instead of going directly to 100 people, let me just stop here and wait for a second and see, how I distribute that based on the accumulated information. And the same thing, if I receive the request from different people, instead of sending that directly to me, they send to Kafka first. Kafka will shuffle them, sort them out, aggregate them, and send it all together. So this is more kind of like it's kind of like the building information model for construction. Like before the building information models, if I have a question, as a designer, I probably just send a request directly to a supplier, to a builder, to an owner, one-to-one. But now we all go to the same BIM model. I can just mark, I have a question here. Everybody can go there and see that. I do not need to copy paste my questions multiple times. Everybody goes to the same place. All you can imagine is Google Doc, that the information, just one copy over there and sending that. So that's a very simple explanation of Kafka, but in general, we have discussed a lot of things today, and I hope you guys can digest that in the next week. First of all, we know that what is big data, right? And we know the biggest thing about big data is the traditional way of doing data processing is not working anymore. And we know why we need big data, because we want to keep pushing our knowledge. But when we start to push our knowledge too much, we start to see encounter the curse of dimensionality. And we do need to cure that. And that way is to bring more data in. How? And also we need to make our sensor and the sensoring more accurate, more precise. How? That is big data. That is probably the temporary solution. I'm not saying that would be permanent solution. I'm saying the temporary solution. And then we talk about the tools that for big data analysis. It's actually really, really big collection of tools like here. There's that. Like really big collection of tools are here, but the most important one is the Hadoop system. And inside Hadoop, you have this Hadoop version of Dropbox, Google Doc, Excel, those kind of stuff. But the most important is the hard disk system, HDFS, and the operation system, which is MapReduce. And the MapReduce is nothing. Just instead of asking one guy to count the number, you have multiple guys to count the numbers and aggregate them together. And we have just designed a system to make that happen. And because the system is so big, the data is so big, we need some additional steps, such as cut into them 128 megabit and give them names, which is the table of content on name node. That's it. That's big data. And you also see from the video, the use of big data is more kind of like the doc. I don't know if you guys use the Microsoft Doc yourself before. It's actually when you want to open C drive, you have to go CD and the C drive. And if you want to create a folder, you use the scripts to create a folder instead of using your mouse. That's big data operation now. So if you want to become a professional in big data industry, this will be your daily life. Writing lines of code to create a new folder, move data, count numbers, remove, store them, duplicate them, all in the form of scripts. All right, so that's what we have. Now we covered the big data. So next week we'll start covering sensors. All right, see you guys next week.